This is Robert Sapolsky, and you're listening to Father-Offspring Interviews.
Hi, everyone. Welcome back to Father-Offspring Interviews.
And as you can see, rather than our usual locale, we are broadcasting live from an underground bunker at an undisclosed location. America, take heart and keep up the resistance.
Well said, comrade. And before we jump into it, I also want to acknowledge that we have just hit the 2-year mark of Determined being published. So very exciting, and thank you all for your support. Okay, to start us off, Sinead from the Dominican Republic says, I've been using a chatbot to figure out my thoughts. Sometimes its answers comfort me, and sometimes they upset me. How can something I know intellectually is not real affect my emotions? Is this a biological glitch?
A glitch, maybe yes, maybe no, but it is something derived from an extraordinary thing we're good at as humans, which is abstraction. Abstraction, somebody skillful can draw some lines on a piece of paper and you can perceive who it's a caricature of. They can draw lines in a more informed way. It gets three-dimensionality. You see that it's Mickey Mouse. You can put lines on pieces of paper and that will carry information. And you can imagine, I'm assuming the Navi did not have a written language, but here's one Navi with a human next to him. And there's another Navi with another human. And the first one whispers to the human saying, tell her to lift her leg. And the human does this strange thing, putting marks on a piece of bark, and goes to the other human without exchanging a word. And that human whispers to that Navi, and that Navi lifts her leg. And whoa, that's amazing. Just markings on a piece of bark, on a piece of paper. What's most interesting is that within this capacity for abstraction, we derive a huge amount of emotion from it. For example, we in our family are obsessed with Survivor, and one of the high points of each season is when they suddenly surprise a subgroup of individuals with letters from home. And it is so great to see these pickled, weather-beaten, hard-assed competitors dissolved into tears as they're reading the letters from home, as they're looking at ink patterns on a piece of paper. We can have that evoked by our real loved ones. We can have that evoked by imaginary creatures. When I was a kid, I was a complete sopping sucker for the last 10 pages of Mice and Men. I read it over and over, and I was always reduced to the sobbing mess amid being able to state not only was Lenny not getting the bunnies, the rabbits, or the ketchup, Lenny was a fictional creature. We could do this in all sorts of ways. We can extend our capacity for abstraction of emotion to people we never see. We can do multi-level abstraction. If you have the right orientation, you can listen to the cannons going off in the 1812 overture, and you can abstract that to meaning Napoleon getting his ass kicked in Russia. And you can abstract that further to what that actually meant, which was hundreds of thousands of troops dying in the cold in Russia far from home. Now, amid that, of course, technology has stepped in. Technology, the printing press, that was technology, but more contemporary ones. And we see technology, chat boxes, AI, and so on, getting closer and closer to us, and thus more powerfully evoking emotional responses. Now, the pioneer of this was in the 1970s, computer scientist at MIT named Joseph Weizenbaum, who came up with this primitive computer program that he called ELIZA. And what it did was it was a caricature of a Rogerian psychotherapist, the work of Carl Rogers. Rogerian, this is the cliched one where all the therapist has to do is basically echo back what the patient is saying to them. What I hear you saying is that, and this was a program that was good at doing that. And human volunteers would interact with it and tell it its problems. And one of the most shocking things to come out of it was a subset of these volunteers preferred doing that with the computer program, with ELIZA. This one great anecdote where Weizenbaum steps out of his office and finds his secretary is there talking to Eliza, the program, and who gets all uptight and says, "Can you stay in your office? This is very private." That's capable of evoking that. And what we're seeing is we're getting closer and closer to that. We have movies like She or Her or whatever it was called with Joaquin Phoenix, where he falls in love with an AI, and that's happening all over the place now. Now, of course, what can happen is things go wrong. And the way that tends to happen is when something comes closer and closer to being similar enough to us to be able to affect emotions, to manipulate us, but where it kind of misses the mark. Like nobody thought of R2D2 as a live thing, and we just thought it was kind of cute. But some of these robotic android things coming out of Japan robotics labs, they're creepy. They unnerve us because they're kind of human and then they miss the mark dramatically. Same thing with corpses that we get creeped out by. Why, it looks just like them, except they are unearthly still and waxen and getting stiff. Same thing in zombie movies. Same thing with really sophisticated puppetry. What we're seeing is this phenomenon called the uncanny valley. In general, as stuffies, as cartoon characters get more and more realistic, we like them more and more. But then there's this point when they get really close to being just like us, but they miss the mark and we get creeped out. We get pulled way to the negative by them. Some of the time, this has been used intentionally. For example, the movie Brother from Another Planet, John Sayles' movie decades ago, these two bounty hunter aliens show up on Earth and they're hunting after our protagonist. And the two aliens come into a bar, and one of them is played by John Sayles. They're both these ectomorphic, tall, skinny, stiff characters with sort of vaguely not human movements. And they come in and trying to pass themselves off as humans. They ask for a drink. They both ask for a beer on the rocks. Oh, something's off there. And they're given their beer, and both of them, in perfect synchrony, drink from their mug and put it down. And they both say, "Ah," at exactly the same time. And you are completely creeped out by them. Toy Story 3, that nightmare baby doll thing, which they made just different enough, just distorted enough from a normal human baby that you're completely unnerved by it, as were all the toys. It was terrifying. Sometimes that happens inadvertently. And there's been a lot of sort of speculation. Why did the movie Cats bomb so dramatically? Because the characters there were evoking uncanny valley stuff. The movie Polar Express also bombed. One reviewer saying because of these animatronic characters there that kind of missed the mark, you felt like you were looking at the Polar Express of the living dead sort of thing. Okay, so we see that, and sometimes that could be manipulated. Sometimes that backfires on us. And of course, you wonder, why do you get this uncanny valley effect? It's our capacity for abstraction to respond to ink on a piece of paper that can evoke the same emotions, by a picture of a loved one, all of that. The uncanny valley, though, is tapping into something biological as well, which is we're creeped out by discrepancy from the norm. And oh, so many episodes ago, we talked about what goes into attraction. Attraction, humans for other humans, various other species, same thing. What comes into being unattracted by? Markers of asymmetry, markers of disease, markers of illness. Mammals the world over, including us, are very attuned to markers of pathogenicity, abnormality, infectivity. And some of the best speculations are that uncanny valley stuff is when buttons are being hit saying, this is someone who is way off the mark, something way off the mark, and they're just tapping into our deep primordial, being creeped out by somebody seeming infectious, especially when it is someone tapping into mate possibility instincts in us. This is the best sense of where it's coming from. Okay, so you see some neurobiology with it, and as stuffies become more human-like, they're ones that are meant to have stuffy versions of faces of familiar characters. And what you see with brain imaging is mirror neurons in the brain become more active, get into the uncanny valley zone, and suddenly you get this explosion of activity in the parietal cortex, the area that's getting all this visual information and trying to integrate it, trying to interpret it, and all of its this does not compute neurons are firing there saying, this kind of seems like one of us, but it isn't, and it's off in a really disturbing way. Our brains are set up to fall for this uncanny valley effect. So, of course, you could get an uncanny valley when you're talking to your chat GPT and getting great advice and deriving emotional comfort from it potentially. And then it does something uncanny valley-ish. So you've got this friend and you're describing how my birthday was a couple of weeks ago, and this really close friend never wished me a happy birthday, seemingly forgot all about it, and I'm wondering, should I bring it up, what I should do about it? And ChatGPT gives you an extremely detailed set of instructions as to how to ambush your friend, pierce him with a crossbow, and then take their heart out and cook them. And that feels a little bit off from what the norm should be. What we see is as we begin to have things like AIs get more and more familiar, more and more close to us, they also have the capacity to evoke uncanny valley effects. Now, all of this may be only a transient phenomenon, and a number of roboticists who think about this stuff have noted that uncanny valleys are going to be disappearing more and more as AIs get better and better, and as more and more they are going to be used by people who grew up with this, where this has been the case forever. We see things are getting more similar. What is always emphasized is in the direction of robots, computers, AIs becoming more like us. What a lot of pundits have pointed out is in the process, we are also becoming much more like the robots. So that is an interesting and potentially worrisome phenomenon.
All right, next, Douglas from Brooklyn says, why do so many animals have white tummies?
Yay, Brooklyn and Douglas. Embarrassingly, this kind of caught me off guard. Over my years out in the field, I spent a vast amount of time glancing over at gazelles and their white tummies and impalas and their tummies, and of course baboons and their white tummies, and never did it register with me how broad this is. This is a very frequent phenomenon across the animal kingdom for animals to be colored much more lightly, even white, on their underside than on their backs. You see this in all sorts of terrestrial mammals. You see this in cetaceans. Whales show that. You see it in fish. You see it in reptiles. You see it in birds. So, of course, the question becomes, is this universal? No, nonetheless, it's very common. And then you come up with seemingly the counterexample, caterpillars. You look at a caterpillar on the floor and its back is lighter colored than its underside. Whoa, that's the exception that proves the rule, because they're upside down most of the time. It's still the part that is on the underside that's lighter colored. And I was very unsuccessful in looking at pictures of sloths and seeing what their undersides look like, and mostly having this very uncanny pull towards how incredibly cute their human-like faces are. So the question becomes, why is this the case? First off, why do so many species have dark coats, dark fur, dark coloration, melanin? And you got a problem, which is you got an animal, for example, living out in the tropics in the savannah, and sunlight, UV radiation, could damage animals just as us and other species get melanomas on occasion. So there's this logic to have some sort of dark coating up on top. And as long as you're at it, it might as well be the same thing on the bottom. Why instead, in so many species, do you have a lighter coloration? And this was something that was first worked out in the 19th century, of course. And this has to do with shading. So you take an animal and you expose them to bright sunlight. It's a quadruped walking around on the ground. You expose them to bright sunlight, and what you get is their back is lit brightly by the light, while their underbelly is darkened in shadow. And what does this do? This creates three-dimensionality. You add shading in the right places, and suddenly you perceive things much more strongly in a three-dimensional way. So what happens when suddenly you got all these organisms with the white underbellies? You get this phenomenon called counter shading. The back, which is dark in coloration, is getting all the sunlight, so it's getting lighter. The bottom, which is light and coloration, is being shadowed, so it gets somewhat darker. The two cancel each other out, and this wipes out the three-dimensionality. What's that good for? Avoiding predators, because it turns out across the animal kingdom, all sorts of predatory species are more likely than chance to have stereoscopic vision, to be able to see in 3D. This is thought to be some sort of anti-predator defense. Really nice work, Olivier Pinocchio, University of St. Andrews in Scotland, modeling different places on Earth, different degrees of cloud cover, rainforest versus open savanna, how much sunlight, how much shading, and coming up with these simulations as to just how bright the underbelly should be, how far up the side it should come up to, and that turns out to be fairly explanatory. So that's why so many species have white underbellies, because of this counter shading phenomenon. Two problems. The first one is you look at some predators and they have white underbellies also. What are they doing with it? So that's a problem. The other confusing thing is you look at species that live underground, like naked mole rats, and they don't have as dramatic of lighter colored underbellies, but they at least still have that tendency. Logically, as one might guess, there are mole species that are completely dark all around and they live underground. But I think what we see with the likes of naked mole rats is some sort of residue of selection back up on the ground for this counter shading phenomenon. So, as you can see, lots more work still needs to be done on the white tummy issue, but at least we have some first hints.
Finally, Helene from Iowa says, there's been a tremendous amount of news coverage about RFK Jr. and President Trump announcing that Tylenol is the cause of autism. Is there some validity to this, or is this misinformation like vaccines and autism?
So happy to get a question like this. Animals having white bellies, it's controversial debates, vituperative backstabbing debates as to why you see whitish bellies on naked mole rats and careers ruined over this. It's so nice to get to a question that's not controversial and just so straightforward. So, what does Tylenol have to do with autism? First off, I would have my license taken away. I would be Jimmy Kimmeled off of this if I didn't have a first introductory sentence to note that autism is a very heterogeneous disorder and is probably a subset of biological processes. So, keep that in mind here. So, we've got this whole issue here of Trump and RFK Jr. announcing the cause of autism along with vaccines. I'm not going anywhere near the vaccine gibberish having to do with autism. That has been disproven debunked, shown to be based on fraudulent science, shown to be based on financially motivated fraudulent science a zillion times. I'm not going near that one. But the new announcement about Tylenol, and specifically its main active ingredient, acetaminophen, that it is one of the major causes of autism. Now, I really don't like a lot of stuff coming out of DC these days, and Donald and Bobby Jr. have much to do with that. But painfully, I have to admit, acetaminophen does have a little bit to do with autism risk. It is not complete raving gibberish like vaccines. There's a little bit of a linkage. What do we have at this point? First off, epidemiological studies, which is look at individuals with or without autism, look at what things their mothers did during their pregnancy. Was there a higher rate of using Tylenol, taking acetaminophen during pregnancy in women whose offspring wound up with autism? Is there something going on there? And there's been a lot of studies looking at this so far, and some of them have very strongly shown a link. Some of them have very emphatically shown that there is no link. Very, very authoritative meta-analysis that came out earlier this year, looking at that entire literature. And the conclusion was the majority of studies do show a link between acetaminophen consumption in the mother during pregnancy and increased likelihood of autism. The study, the meta-analysis, revealed something very helpful, which is the more acetaminophen was taken during pregnancy, the more of a correlation. That is the sort of thing you're looking for biologically. Unfortunately, there were not enough studies and done in sufficiently different ways that you can't ask whether it was a linear or nonlinear relationship between the amount of acetaminophen taken and outcome. What do I mean by that? Linear, for every smidgen more acetaminophen taken during pregnancy, increased odds of autism. Non-linear, for every increased smidgen, not really a big difference until you get in the very high range and suddenly it shoots up. Some of the studies seem to suggest it's more the latter. This is a phenomenon of women who have taken a lot of acetaminophen during their pregnancy. Now, I have to bring up something kind of ironic here in that this very authoritative meta-analysis that said, yes, there's something about acetaminophen that makes sense here, was carried out under the leadership of Andrea Baccarelli, who's the chair, the dean of the Harvard School of Public Health. I sure wonder if they've had their funding cut in the last 8 months, given that they're providing the strongest support for this. The strongest support, nonetheless, not very strong. What does the meta-analysis show? Knowing about exposure prenatally to acetaminophen explains about 18% of the variability and outcome, represents about an 18% increased risk. That's not a big effect. The same meta-analysis showed, for example, that prenatal exposure to acetaminophen has about a 33% increased risk of ADHD. What we have here is there's a small effect. There's a small effect. Now, from where I come from, epidemiological studies are sure nice, although I usually get lost in the statistics. What I look for are biological mechanisms. How might this work? And again, the same conclusion. There's little bits of threads there that connect prenatal acetaminophen exposure with the brain changes associated with autism. Now, what's known about the autistic brain? The brain of individuals with autism, once again, super heterogeneous, but one of the interesting findings, one of the more consistent ones, is on the average, during the first few years of life, the brains of individuals who are destined to be labeled with autism tend to be larger than average. And this has been explored in some detail. It is mostly occurring in the cortex. It is not due to more neurons, it is due to more connectiveness among the neurons, more white matter, which is what you see that represents the cables connecting neurons. Interestingly, adding to this mystery further, if there's more cables, more connectiveness, you would guess that this is connections across the brain. What you see is not only more connectiveness, but localized. And what this literature also shows is this most dramatically is occurring in the frontal cortex. So, over expansion of the brain during the first 3, 4 years of life, and then other kids catch up and the difference tends to disappear. Where might this overproduction of connectivity in the brain, the postnatal brain and the cortex and the frontal cortex, be coming from in these individuals? And what you look for are some of the usual suspects when you look at stimulation of brain development: growth factors, jargon, neurotropic factors. And the one at the top of the list is this one called BDNF, brain derived neurotropic factor. And that appears to play a big role in prompting the developing cortex to increase connectivity. Okay, so does BDNF come into this picture? Yeah, a couple of studies showing at birth, you look at blood in the umbilical cord, which is reflecting from the fetus as well as from mom. You look in there, and kids who eventually develop autism, elevated levels of BDNF. Just a handful of studies showing this, and totally indirect because you're trying to figure out what was going on in that fetus's brain by looking in the umbilical cord. Very indirect. Nonetheless, that fits with the picture that one of these brain growth factors seems to be, at least one of them seems to be overactive in these cases. This one finding here of elevated levels of this BDNF growth factor. So, where does Tylenol, where does acetaminophen come into this? And what we have by now is a literature showing that acetaminophen getting into the brain, especially in young animals, laboratory animals, not humans, so all the caveats there, that acetaminophen can increase the expression of the gene for BDNF, can boost up its levels, in particular in the frontal cortex. So at this point, that's basically the literature. And like the official thing I have to say in my business is these are provocative findings. These are compelling findings, compelling you to do more research to see about this connection. But at least there is this link there. But we're still left with this issue that acetaminophen exposure only increases likelihood like 18%. It does nothing in most people. Why is this only a subset of individuals where whatever this effect is might have been going on? And what you see here is this world of pharmacodynamics. What happens when you take Tylenol? The vast majority of it goes to your liver, where the acetaminophen in there, remarkably, is broken down. It's degraded, like 95% is broken down, and the remaining 5% is dumped back in the bloodstream. So tiny amounts in the bloodstream going everywhere and coming to the brain, where you get this thing called the blood-brain barrier that's pretty good at keeping out stuff that doesn't normally get into the brain. There's these extrusion pumps that extrude chemicals, xenobiotics and stuff that get past the blood-brain barrier. They get grabbed by these transporters, get thrown out, and they toss out about half of the acetaminophen that's getting to the brain. So notice 95% of the stuff is broken down in the liver, and then of the remaining 5%, about half never gets past the blood-brain barrier. All of the pharmacological effects of acetaminophen, of Tylenol, are coming from a tiny, tiny percentage of the stuff getting into the brain. So where might individual differences come in? And there's no shortage of possibilities. Individual differences, genetic differences, epigenetic differences in how much your liver breaks down acetaminophen. There's even a very minor breakdown product of acetaminophen that in and of itself is neurotoxic, individual differences in what's going on in the liver. And note, you get a liver that's a little bit less effective at breaking it down, so it breaks down 90% instead of 95. You've just doubled the amount of this stuff being dumped back in the bloodstream. It's a system that's near saturation. So very small individual differences can make a big difference in what's winding up in the bloodstream. Next area where individual differences can come in, how good the blood-brain barrier is at filtering out stuff that you don't normally find in the brain. And of course, the third domain is individual differences, genetic, epigenetic, and how readily whatever it is acetaminophen is doing to activation of the BDNF gene, why it happens more in some individuals, less in others. Okay, so in theory, that's where all the individual differences come from. Really intriguingly, a paper a couple of years ago looking at the genomes of women with offspring with autism, looking at the genomes and looking for what differences there might be. And one of the things that popped out in a subset of the individuals was mutations in the gene coding for one of these pumps in the blood-brain barrier that's good at keeping stuff out. What they don't know is if that's the pump that pumps out acetaminophen. There's all sorts of stuff needed to be filled in there, but nonetheless, little bits and pieces of the story are falling together. So there's this thread here linking the brain overgrowth seen in autism, BDNF, with some of the actions of acetaminophen, a thread, very minor. One other small piece of the story, acetaminophen in brain tissue in experimental subjects in lab animals increases production of oxygen radicals, inflammation, not gigantic effects, but that could be part of the story as well. So what can we do here with a conclusion at the end? Genes have something to do with it. Environment has something to do with it. Genes, when you do classic behavior genetics on heritability of autism, you see it's moderately heritable. It is not genes causing the disease. When you look at environmental exposure, for example, acetaminophen as the current usual suspect, we see it's only explaining an 18% increase. It's not just environmental exposure alone. You got the usual textbook genetic vulnerability interacting with environmental vulnerability. So what do we do with this at the end here in terms of the nuanced advice that came out of DC the other month? I believe Trump summarized his statement with don't take Tylenol, don't take Tylenol, fight like hell to not take it. That's sheer nonsense at this point. What it looks like is in a subset of individuals with a certain genetic vulnerability who take a lot of Tylenol, acetaminophen during pregnancy, there's a little bit of an increase of autism as an outcome, and we've got a first couple of hints as to what's going on in the brain. That's the state of knowledge at this point.
And that concludes episode 83. I'm Offspring Sapolsky, and thanks for your continued support of science and the beard.